Today I'm going to show you, we're going to do a walkthrough of one of our assignments, Deliverable Assignment Lab 1. So the reason we're going to kind of walk through that with you is because this is the first time we're going to be using the flowcharting software and we're going to be designing pseudocode. So I want to just kind of walk through this project with you. First thing we want to do is go to Blackboard. We'll go to our Blackboard site, which as you can see I'm already here. And we're going to click on Content, and then we're going to go to our CIS150 assignments. And this is a deliverable lab, so we're going to click on CIS150 Deliverable Labs. And we're doing project 1. Well, if you look, it says complete exercise 15 on page 29 of the text. Create both the flowchart and the pseudocode. We're not going to use visual logic yet. We're only going to do the flowchart and the pseudocode, not an actual program. And it says submit your assignment in the form of either a ClickChart file or a Visio document, a Microsoft Visio document, not Visual Logic. You can use either one of these for the flowcharting software. I would prefer you use these two because when you turn it in, it has to be in a format that I can actually look at, which means I have to have the program installed on my computer also. And these are the only two flowcharting software programs I have on my computer. If you submitted it in anything other than ClickChart or Visio, I won't be able to read it, and so I can't grade it. But first thing we're going to do in this little walkthrough, we're going to use ClickChart. I have put a link to the ClickChart file, to the ClickChart program. It's a free program you can download and install on your computer. That link, again, is under Content. If you scroll down to the bottom here, it says Required Software. If we click on that, you can see I have the Visual Logic download page, which again we're not using yet. We will use it most of the time in this course, just not this particular project. And you've got ClickChart's diagram and flowcharting software. I'm going to go ahead and click that, and you'll see I'm running Microsoft Edge, so it automatically downloads it right down here at the bottom. And it's finished, so I'm just going to click Run to install it. I'm going to accept the license terms, click Next, and it should install pretty quickly because it's a small program. Once it installs, it will open up like this. And we would just click Create New. But I'm going to click Blank Diagram to start a new flowcharting program. And this is your flowcharting software. I'm actually going to minimize this right now, get it out of the way to get back to Blackboard because I want to go back to my project in my lab. Click on Content, back to CIS150 Assignments, Deliverable Labs, and I'm going to click on Project 1. Now this says flowchart and pseudocode. When you're doing both of these, you always want to do your pseudocode first. So do your pseudocode in either Microsoft Word or Windows Notepad. I'm going to use Windows Notepad for this. So I'm just going to go down here and type in Notepad. And it pops up right here, and I'm just going to click on it to open it up. And as you can see, it's just a text editor is all it is. Now, as I said, first thing we want to do is create our pseudocode. So this is where we're going to create our pseudocode. When you're creating pseudocode, the very first thing you want to type is the word start. I'm going to hit the enter key, and I'm going to space over about 3 spaces to indent. Now the next step in creating your pseudocode is you want to declare and initialize your variables. So we need to go back to our problem here that we're trying to solve, which, as you can see, complete exercise 15 on page 29 of the text. So I'm going to read that to you. Page 29, problem 15 says, develop the logic of a program that allows the user to enter his or her hourly pay rate, the number of hours worked this pay period, and the percentage of gross salary that is withheld. The program multiplies the hourly pay rate by the number of hours worked, giving the gross pay. Then it multiplies the gross pay by the withholding percentage, giving the withholding amount. Finally, it subtracts the withholding amount from the gross pay, which gives you your net pay after taxes. The program then displays the net pay. So we want to take this a step at a time. Like I said, the first thing you want to do is declare and initialize your variables. So right here I'm going to type in declarations. And I'm going to go down and I'm going to space over that 3 and then another 3, because this is where we're going to declare our variables. If we look at the problem, let's just take it a sentence at a time. Develop the logic of a program that allows the user to enter his or her hourly pay rate. So we know we're going to be entering the hourly pay rate. So hourly pay rate is going to be a variable because we have to have a variable to hold that information. And we know the first thing we have to do is set the data type. We know the hourly pay rate is going to be a number, so it's going to be numeric data type. So I'm going to type num, which sets the data type for this particular variable. And I'm going to name our variable pay rate. You can name it anything you want it as long as it's very descriptive. I'm just going to name it pay rate. And you notice how I type that small p and then a capital R? That's called camel casing because it's got that hump in the middle. That's the format we're going to use to name our variables. We're going to use camel casing, and it talks about camel casing in the book a little bit. But that's the format we're going to use. Now we have declared our variable. We've declared a numeric variable named pay rate. But we're also going to initialize it. If you don't initialize it, the computer will automatically assign it garbage. We don't want to do that. We want to know what this variable is holding. So I'm going to put equals and 0. So I've declared a numeric data type variable named pay rate, and I've initialized it to the initial value of 0. So then I'm going to go to my next line, and I'm going to continue with the problem. Input the number of hours worked this pay period. So that's going to be another variable, the number of hours worked this pay period. And of course the number of hours worked is going to be a numeric data type. So I'm going to go num, and I'm going to just name this one hours. And I'm going to initialize it to 0. Left out a space there. There we go. That's our second variable. Well, let's continue reading the problem. After that it says, and the percentage of gross salary that is withheld. So you need a variable to hold the percentage of gross salary that's withheld. Again, a percentage is going to be a number, so it's going to be the numeric data type. And I'm going to call this one percent withheld. And I'm going to initialize it to 0 again. So that's 3 variables. Well, if we continue reading the problem, it says the program multiplies the hourly pay rate, which we have up here, by the number of hours worked, which we also have, and that gives you your gross pay. Well, you need a variable to hold that gross pay, and we know it's going to be a number too. So numeric, and I'm just going to call it gross pay. And I'm going to initialize it to 0. So that's the 4th variable we need in this problem. Well, let's continue reading. Then it multiplies the gross pay by the withholding percentage, giving the withholding amount. Well, we're going to need a variable for the withholding amount also. And withholding amount is, again, going to be numeric. So num, and I'm going to call this amount withheld, AMT. And again, it doesn't matter what you name your variables as long as they're clear, as long as you can look at them and tell what type of data goes in there. And I'm going to initialize again to 0. Well, that gives us 5 variables. Well, let's continue reading the problem and see if we need any more. Finally, it subtracts the withholding amount from the gross pay, giving the net pay after taxes. Well, we need something to hold the net pay, so we need a variable for that too. And once again, net pay is numeric, so num, and I'm just going to call it net pay, and I'm going to initialize it to 0. And that is all the variables we need. So that's 6 variables that this problem needs. And we have declared the variables and initialized them to an initial value of 0. So now what we need to do is, our next step would be input. We want the user to input the pay rate, the hours, and the percent withheld. So when you're using pseudocode, you can actually, that's 3 inputs, but you can actually combine them on one line in your pseudocode. So I'm going to type input, and you notice how I lined that up with the declarations. It's very important how you indent. It makes it a lot easier to read. But we want to input the pay rate and comma, and we want to input the hours worked, which we named hours, so it's URS, and the last thing we want to input is the percentage of gross salary that's withheld. We call that percent withheld, so percent withheld. And that's all of our inputs. When you're typing your inputs, you want to be very careful, pay particular attention to use the same name that you named that variable. Type it exactly the same way. For instance, pay, where I said input pay rate here, you'll notice I did that exactly the way I declared that variable, because it's saying input that variable, input that variable, and input this variable. So once we've got our input, the program multiplies the hourly pay rate by the number of hours worked. So we need a compute statement, right? So we're going to type, and since this is pseudocode, which means fake code, we can just use English. So we're going to say compute. What are we computing? We are computing gross pay. So we're going to say compute, and again type it exactly like you declared the variable, gross pay as pay rate times, and the little asterisk is the times symbol, times hours. That gives you your gross pay. You can't combine the compute statements as you did the input statements because it's different computations. So now that we have this, we've got our gross pay. But now we need to do some more computations, because it says then it multiplies the gross pay by the withholding percentage, giving the withholding amount. So we need to compute the withholding amount. So we're going to have another compute statement, and we named withholding amount withheld. So compute AMT held as the withholding amount is the gross pay times the percent withheld. And again, pay particular attention to the way you type this. You want to type it exactly the same, this variable name, exactly the way you typed it up here when you declared it and initialized it. So now we have the gross pay and we have the amount withheld, excuse me. Now the problem says finally it subtracts the withholding amount from the gross pay, giving the net pay after taxes. So we need to compute the net pay. So we're going to have another compute statement. We're going to compute the net pay as the gross pay minus the percent withheld, the amount withheld. And that gives us, that's our 3 compute statements that we need. Now the last part of the problem, it says the program displays the net pay. So that is an output. So we need an output statement here. We're going to go output net pay. And then of course we're always going to end our program with a stop statement. And that is your complete pseudocode right there for this particular problem. So what we're going to do now is I'm going to click File, and I'm going to click Save As. And I'm going to save it to my jump drive. Remember, we set up these 3 folders, and this is a deliverable lab, so I'm going to double click on deliverables, and I'm going to create a folder called Lab 1. And I'm going to go into that folder, and this is my pseudocode. So down here in the file name, I'm going to name it pseudocode. And I'm going to click Save. Now I'm going to keep this open so you can see it. I'm just going to try to drag it over here to the side like this. And now we're ready to do our flowchart. So let me find my flowcharting software, which I have already downloaded. And there is my ClickCharts diagram flowchart software. I'm going to open it up. And I'm going to put this on this side of my screen here so that you can see my pseudocode and my flowchart at the same time. Let me resize these just a little bit. Okay. Now we've got our blank flowchart document open here. Let me zoom in just a little bit. There we go. Now you'll create your flowchart by using your pseudocode over here. You remember, a flowchart is just a visual representation of your pseudocode. So the first thing we want to do on our flowchart is put our start symbol. If you look at your flowchart symbols here, that first one says start and end. That's going to be our first symbol. We're just going to click it. Going to come over here, click right there, and then we're going to just double click inside that circle. We're going to type the word start, just like we did in our pseudocode. And again, let me make this a little bigger so you can see it better. And that's our start symbol, just like we have in the pseudocode. Now the next thing we have is our declarations. The declarations we'll use a process box to do our declarations in. It's the rectangle here. It's the same as a compute box. So we're going to take this, and I'm going to bring it right over here, click, and I'm going to resize it just a little bit, just because we've got a lot of declarations there. Notice how it automatically put my little line there, my little connector line. That shows me the way the program flows. Trying to get that line straight. There we go. Shows the way the program flows, and it will automatically put these connector symbols in there for you. So what we want to do here, we're going to put all of these declarations here in this box. So what I'm going to do is I'm just going to highlight these declarations here. I'm going to right click and click copy. Then I'm going to double click inside my process box, and I'm going to right click and click paste. That put all of my declarations in here. What I should have done is actually, let me resize this a little bit more. What I should have done is put the word declarations. And a colon. Now I don't like this centered like this, so what I'm going to do is left align it. Just like that. Now I've got my declarations here, and everybody can look at this and tell that it is declarations. I have 6 variables that I've declared and initialized to 0. Now if I look at my pseudocode, the next step is input, correct? Well, on a flowchart you can combine these inputs into one symbol also. You don't have to have 3 different symbols. So our input output symbol is this parallelogram. So we're going to click it, bring over here, and put it just under that. And again, I'm going to resize it to make it a little bigger. You notice how these little dotted lines appear as I move that? That will let you know if you're lined up or not. I'm going to go over here and I'm just going to highlight this from my pseudocode, copy it, double click in my parallelogram, right click and click paste. And there's your input statement. I'm actually going to make this a little bit bigger, simply because to me it looks better if I can get it on one line. You don't actually have to get it on one line, 2 lines are fine. I'm just crazy that way. I just like it on one line. It just looks better to me. But you can, if yours is on 2 lines, that's absolutely fine. Nothing wrong with that. Now the next thing we need to do is our compute statements. Well, you can't combine those, so we have to have 3 compute statements here. This is a process box right here, just like the declaration box. So we're going to put a process box right here. And I'm just going to copy that first compute and paste it right in here. And again, I'm going to resize it to make it look a little better. And that's got our first compute. Now, you may have to rearrange these, drag them in up, make them a little closer together if you run out of room. So I need 2 more of these process boxes. Again, I'm going to go ahead and resize them to the same size as that last one. And I'm going to put this second compute statement in it, where we compute the amount withheld. And I'm just going to leave it on 2 lines like that because I'm kind of running out of room here. And now we need a third compute statement. I'm going to come down here and do this one. And I'm going to copy this last compute statement. And we're just going to paste it right in there. And I'm going to resize that just a little bit, just simply because I am running out of room. As you make these narrower, it'll make the text smaller. And again, what I'm doing is just making it look a little bit better. This is not really necessary. Right, we have our start, we have our declarations, we have our input statements, and we have our compute statements, our 3 compute statements. So if we look at our pseudocode, what's next is our output statement. So we need to get an input-output box. The output box is the same as the input box. It's known as an input-output box. So we are going to click right here, and I'm going to make it a little bit smaller right off the bat. And I'm going to copy my output statement from my pseudocode and paste it right into that output box. And now the very next thing is our stop statement, which is the exact same symbol as the start. So I'm just going to come down here, put that there, resize it a little bit, double click and type stop. And I am going to center that. Now I'm going to close my pseudocode because I've already saved it. And I'm going to make this a little bit bigger so you can see it, so you can see the entire thing. This is what your pseudocode, your flowchart should look like. That is the flowchart for that. So we've saved our pseudocode. Now we're going to save our flowchart. So I'm going to click File, Save As, and again I'm going to go back to my USB drive, back to my deliverables folder, back to my Lab 1 folder, and for the file name I'm just going to name it flowchart. And I'm going to click Save. Now I've got all of that done, So what I need to do now is zip it up and turn it in. So I'm going to click on my little file explorer down here, go to my flash drive or my thumb drive or whatever you want to call it, my USB drive, go back to the folder that I saved all of those in, and there's my flowchart and my pseudocode. Now what I'm going to do is I'm going to just highlight both of those or select both of those. I'm going to right click on it. I'm going to go to send to, and I'm going to go to compressed zip folder. What that will do is it'll turn both of those into one file. Notice it does that, and I'm going to name it, and this is the naming convention I want you to use from now on. I'm going to name it Deliverable Lab 1, and then I'm going to put an underscore, and then I want you to put your last name and your first name. In my case, I'm going to put Kelly Mark, and I'm going to hit my enter key. That's the way I would like you to name your zip file, and that will be the file that you will actually submit through Blackboard. Don't submit these two individually, just submit this one zip file, and zip it up, name your zip file just like that, Deliverable-Lab1 or Lab 2 or 3, or whichever one you're working on. Or if it's in class and you have to do two files, just do in class-lab1 underscore your last name, your first name. Now what I'm going to do is go back to Blackboard, and I'm still here at the assignment project 1. I'm going to click attach files. I'm going to click browse my computer, go to my flash drive or USB drive, and there's that zip file I just created. It would say out here under type, you'll notice it says compressed zipped. I'm going to click on that and click open, and if you'll notice, it attaches it right here. And then I'm just going to click submit. Now when I click submit, it's not really going to submit mine because I'm the instructor. When you click submit, it will actually submit yours, and I can download it and grade it. I'm going to click submit, and where mine says submission form previewed assignment is not saved, yours won't say that. Yours will actually save it. And that's all there is for this particular assignment. If you have any questions, just remember always, don't hesitate to email me or contact me in any way. And I'm going to be doing several more of these little video recordings so you can kind of helping you go through the in-class labs and some of the deliverable labs. I will see you guys next time.